All right, guys. Hi, welcome back to another lesson with mathematics. My name is Sam, and today I will be teaching you guys about trigonometry functions, primarily SOHCAHTOA, which is the mnemonic for sine, cosine, and tangent. To some of you guys, this might be a foreign language right now, so I will go ahead and explain it in detail. This was a challenging topic for me when I was in high school, as well as middle school. So I just figured I'd try to explain it to you guys because this is actually something useful that you use all the way up until college as well. So it's very important to know this mnemonic, remember it, because it's very, very helpful in remembering or solving uh, questions dealing with right triangles. So let's get started. So sine, cosine, and tangent are functions in trigonometry that relate an angle with two sides, primarily in a right triangle. So as long as there's a 90-degree angle, it's a right triangle, and you can use these functions to figure out the sides in a right triangle. So based off of this image I am showing right here, we have an angle with that we're just referring to as theta. And then we can see that this is the 90-degree angle right here, which is depicted by this small box that they have drawn here. Now, I'm going to talk about the mnemonics. SOHCAHTOA. So is in relation to sine, which means the opposite over the hypotenuse. And by what I mean is, by opposite over hypotenuse, what I mean is, in relation to this angle, which we have marked theta, this side is the opposite, so in relation to this angle, and this side is the hypotenuse, which is always actually the longest side in a right triangle, and this is the adjacent side. So we're talking about these all in relation to this angle theta. If this angle was theta, if we had this symbol moved over here saying that this is theta, this side would be the opposite side in relation to theta, and this side would be the adjacent side in relation to theta. So it's different. The opposites and adjacents are always different in relation to where theta is. But the hypotenuse is always the side with the longest side is always the hypotenuse. So just remember it as the long side is the hypotenuse, and then the adjacent and the opposite will change whether you're talking about this angle or this angle, or even this, well, not the right angle, the other two angles. So all the angles other than the right angle, the adjacent side and the opposite side will change. So so if I had the angle measurement of this, let's say it's 30, in order to find either the opposite or the hypotenuse, whichever value I don't have, I would just type into my calculator sine of theta, so whatever angle measurement that is equal to, let's say I have the opposite value, but I don't have the hypotenuse. Let's say the opposite value is 5. In my calculator, I would say sine of theta is equal to 5 over the hypotenuse. And then I would just solve for the hypotenuse, which I can, essentially just label as x. And that would give me the value of what the hypotenuse is. And then using those two values, I know I can find the adjacent value by using the Pythagorean theorem. And this will all make sense once I go over an example for it. For ka, we can remember it as adjacent over hypotenuse. So as long as I have one of these two sides, as long as I have either the adjacent or the hypotenuse, I can find out what the other side will be. And then for TOA, as long as I have either the opposite or the adjacent side, I can find out what the other measurement will be, the other angle side will be. Sorry, I said angle side, the other triangle side will be. So these are three easy mnemonics to remember, SOHCAHTOA, in relation to sine, cosine, and tangent. So let's go over an example. So this question is saying, given the following right triangle, solve for the missing side length r. Here we are given one angle measurement is 90, one is 20, and then we are asked to and just know what the third measurement will be, which I already explained. Let me get my pen out. So we know that the total value inside of this right triangle has to equal 180 degrees. So what I can do is subtract 90 and 120 from the 180. And what do I get? I'm going to type this into my calculator. So 180 minus 20 minus 90, I get a value of 70. So I know that this, I'm just going to call theta, is equal to 70 degrees. So that is equal to 70 degrees. Now, I'm asked to figure out what length r is, and in order to find r, like I said, the opposite side or the adjacent side will vary whether you're talking about this angle or whether you're using this angle or if you're using this angle. In this case, let's say I want to use this angle. So in relation to this angle, this will be the opposite side. This will be the adjacent side. And this will be the hypotenuse. And I know that because it's the longest side. We don't know what the value is, but you can tell that this will be the longest side in this right triangle. So using, so since I know the opposite and the hypotenuse, what mnemonic can I use? Can I use cosine, which is ka? Do I have the adjacent? No, I don't. And I don't have the hypotenuse either. So I can't use ka, can't use cosine. Can I use TOA? Yes, I can use TOA, but in this case, I don't want to do too much work. If I did use TOA, I would essentially be finding the adjacent side, and then I would have to use the Pythagorean theorem to find side r. So how about because I do have the opposite side, but I don't have the hypotenuse. So why don't I just use so? So in this case, I type into my calculator sine of 20 is equal to, so sine of 20 is equal to opposite over hypotenuse, so 10 over the hypotenuse, which is also the same as side r. I'm just labeling it as the hypotenuse. And then I just solve for h. So in my calculator, I type in sine of 20, 10 divided by sine of 20 is equal to 29.23. So r is equal to 29.23. And then if I'm not exactly 100% sure if that is the right answer, I know I can go back and do the Pythagorean theorem, which is a squared plus b squared is equal to c squared, and double check to see if I get the value of or if that it ends up being my true value. So you can always double check that if you're asked to even find the value of a here. And then I have a couple more examples. So in this case, I just typed up all the work just so it would be easier for you guys to follow along. It's since I have to draw with my computer mouse pad, I think sometimes the handwriting can get pretty messy. So I figured typing it up would be better for you guys to understand it. And it's always there when you guys need to refer back to it. Anyways, we're gonna solve all three of these problems step by step, and I'll walk you through each step of it. So in this first triangle, we have the values of two of the angles, and then we have to find the value of the third angle. We're not asked for it in this example, but I always like to make sure that I have all the values of the inside the right triangle, just in case I want to use it in order to find the side lengths. So in this example, I know one of the sides is 90, one of them is 45. I just do 180 minus 45 minus 90, and the other angle will equal 45. So I know in this case that theta is 45 degrees. Now, in this example, I'm going to use tangent. So tangent, the mnemonic is TOA. So in order to use tangent, do I have the opposite side as well as the adjacent side? Or one of them at least? Yes, I do. I don't have the opposite side, but I do have the adjacent side. And then using the formula tan of 45, or tangent is equal to opposite over adjacent, I can find out what the opposite side is. So in my calculator, all I type up is tangent of 45, because I originally found out what this angle is. So tangent of 45 is equal to opposite, which is x, over adjacent, which is 5. And then I simply solve for x, and I get a value of 5. So x is equal to 5. Let me get a pen out. Excuse me. So x is equal to 5. I always like to write it over here too. And then using the Pythagorean theorem, I can do a squared plus b squared. In this case, it doesn't matter which is a squared. This can be a squared, or this can be a squared. Doesn't matter, and vice versa. Either one can be b squared. We just have to make sure that the longest side, the hypotenuse, is c squared. So in this case, we're asked to find y, which is c squared. So I just do 5 squared plus 5 squared is equal to c squared. And essentially, I get 7.07 as my answer for y. You can see how it gets a little messy, but in quarantine, this is the best that we can do to teach online. Anyways, so for the second example, here we are given new angle measurements. So one of the angle measurements is 90, one of them is 30, and then we're asked to solve what the third angle or the sides x and y will be. But as I mentioned, I like to kind of figure out what the third angle measurement is as well in this case. So I do 180 minus 30 minus 90, and I get theta to be 60 degrees. And then to find x, I'm going to use cosine this time. So I'm going to refer to theta right here, which is 60 degrees. So I'm going to use this angle measurement to figure out what sides x and y are. In this case, let's do x. So for cosine, remember the mnemonic is ca. So if we refer back to this page, for cosine, the mnemonic is adjacent over hypotenuse. So the adjacent side in relation to this angle measurement will be 9. So I have 9 up here, and then so the adjacent side will be 9, and then the hypotenuse side will be x. So once again, I just solve for x, and I get a value of 18. So put 18 here, and then in order to find the value of y, so side y, just once again, you do the Pythagorean theorem. You get a squared plus b squared equals c squared. In this case, we know that this is the hypotenuse, so c squared will be the hypotenuse value since it's the longest side. And then for y, I get a value of 15.58. So let me get my pen out. 15.58 is the value for y. So I'm going to put that up here. And then I noticed that my answers for this problem disappeared, so I'm just going to write them in again. Okay, and then for x, I had 5. And in this case, x is equal to 18. And we can see that the hypotenuse is the longest side, or sorry, here, 18 is the longest side in reference to 9 and 15.8, as well as in this case, x is 5, the adjacent side is also 5, and the hypotenuse, which is the longest side, is 7.07. Now, in the third example, I didn't show all my work, but I figured you guys could follow along and hopefully do this on your own as well. So once again, we just have to find what the angle measurement of the third angle right here is. So theta, I do 180 minus 90 minus 60, and I get that theta is equal to 30 degrees. And then in this case, I wanted to use sine. So just so you guys could see how to use each one of the functions. So sine of 60, we remember that sine is meaning, so referring back to SOHCAHTOA, sine is opposite over hypotenuse. So in relation to this angle, this is the opposite side and this is the hypotenuse. The hypotenuse always remains the same, but the adjacent and the opposite can change. So sine of 60 is equal to the opposite side, so x, over the hypotenuse, which is 22. And then solving, I get that x is equal to 19. And once I input these answers to the Pythagorean theorem, I get y to be 11. And I went over the Pythagorean theorem in a couple of previous videos, so you guys can always refer back to those in case you need help. But I also have it written down here, a squared plus b squared is equal to c squared. And remember, a squared and b squared doesn't matter which side is which. This could be a squared, this could be b squared, or it could be vice versa. We just have to make sure that the longest side is going to be c squared. And that should hopefully get us to our answer. So SOHCAHTOA are very, very useful mnemonics that you can use to remember sine, cosine, and tangent, and how to find, the missing side angles when you, or the side lengths when you have one of the angle measurements, or if you're trying to find the second side length, if you have one of the angle measurements, very useful. You're going to use it throughout high school, throughout college, probably even after college. So it's really important that you guys do remember it and practice, because it seems like it's very challenging, but it can actually get very easy. It's a piece of cake once you do enough problems and kind of get familiar with the whole idea of it. But hopefully you guys found this video useful. Let me know if you guys have any questions, and hopefully I can answer them in the next video. Take care and stay safe.